Nvidia risked collapse before it owned the future. The bet that made Jensen Huang rich started with something much less glamorous than AI, making video games draw faster. That is the strange part of the story. The company near the center of the AI boom did not begin with chatbots, giant data centers, or a plan to power the next generation of intelligence. It began with three chip people looking at computer graphics in the early 1990s and asking a simple question: what if the future of computing needed a different kind of engine? Most founder stories get cleaned up after the money arrives. They make it sound like the winner saw everything from the beginning. The more useful version is messier. Jensen Huang and his co-founders saw a direction. Then they spent decades surviving long enough for the world to catch up. Huang co-founded Nvidia in 1993 with Chris Malachowski and Curtis Preem. The rough idea was that personal computers were getting more visual, games were getting harder to render, and the normal CPU was not built to handle every pixel, shape, shadow, and texture by itself. Graphics looked like a niche. A fun niche, maybe, a gaming niche, but inside that niche was a very hard computing problem. If a chip could draw a moving game world quickly, it had to do many small calculations at the same time. That mattered more than it sounded. The first version of the bet almost failed. Nvidia's early chip, the NV1, was built around a graphics approach that did not become the industry standard. The market moved toward triangles. Nvidia had gone another way. That sounds technical, but the business lesson is not technical at all. They were building an expensive product in a young market, and they had guessed wrong about the rules. This is where the clean founder myth usually skips a page. Nvidia was not obviously destined to win. It had to change direction fast enough to stay alive. The company moved toward the triangle-based approach the market wanted. The pivot hurt, but it taught Nvidia something important. Being right about the future is not enough. You also have to be compatible with the present. That lesson shows up again and again in the company. Nvidia kept making big bets, but it did not simply sit there waiting to be proven right. It adapted the bet. It survived the ugly middle. Then came the GeForce era. In 1999, Nvidia introduced the GeForce 256 and pushed a new word into the industry: GPU, short for Graphics Processing Unit. The name mattered because it framed the graphics chip as more than a helper. It was not just an accessory attached to the real computer. It was a processor with its own job, its own identity, and eventually its own future. At first, that future still looked like games. Better graphics, faster frame rates, more realistic worlds. That was a serious business on its own. Gamers wanted better hardware. Developers wanted more power. PC graphics became a place where Nvidia could compete, learn, and keep funding the next version of the machine. But Huang's real, long bet was hiding underneath the gaming story. A GPU was good at doing many similar calculations in parallel. Games needed that, but so did physics simulations, scientific computing, medical imaging, weather models, oil exploration, financial modeling, and eventually machine learning. The same basic pattern kept appearing: lots of math, repeated again and again, across huge amounts of data. The problem was that most people could not easily program a graphics chip for those other jobs. That is why CUDA matters. CUDA was Nvidia's software platform for letting developers use GPUs for general-purpose computing. In plain English, it made the graphics chip feel less like a sealed box for games and more like a tool programmers could build on. This was not an obvious money machine at first. Software ecosystems are slow. Developers need tools, documentation, examples, libraries, patience, and a reason to bother. Researchers do not rebuild their work overnight because a chip company says the future is parallel. Companies do not rewrite their systems unless the payoff is large enough to justify the pain. For years, CUDA looked like the kind of investment that only makes sense if you believe the same hardware trick will matter in many different markets. That belief became Nvidia's moat. Competitors could try to build fast chips, but Nvidia was also building habits. Researchers learned its tools. Engineers wrote code against its libraries. Universities taught students on its stack. Companies built systems assuming Nvidia hardware would be there. Every year the software got deeper, the examples got easier to copy, and the cost of leaving got a little higher. This is the part of the Nvidia story that feels boring until it becomes obvious. The chips were the visible product. The software ecosystem was the quiet lock-in. The gaming business funded the long experiment. Nvidia did not jump from games to AI in one magical leap. It used one market to survive while preparing for a much larger one. Then deep learning arrived with a loud hint. In 2012, AlexNet used GPUs to train a large neural network that performed dramatically better than prior systems in the ImageNet competition. That moment did not single-handedly create AI. Researchers had been working on neural networks for years, but it helped convince a lot of people that deep learning plus GPU acceleration was not a side trick. It was a path. Suddenly, the thing Nvidia had been making for years looked useful for a different reason. GPUs were not just drawing explosions. They were helping machines recognize images, process language, recommend videos, and train models that needed huge amounts of math. Still, the payoff took time. Data centers did not rebuild themselves overnight. Cloud companies had to buy hardware. Researchers had to scale models. Software had to mature. Nvidia had to move from selling cards into selling platforms, systems, networking, libraries, and full stacks for AI computing. That is why the Jensen Huang story is not just AI made him rich. It is more specific than that. He stayed attached to a belief that accelerated computing would matter before the market fully agreed. Nvidia kept making the chips faster, kept making the software deeper, and kept turning the GPU from a gaming part into a general engine for hard computation. Then the ChatGPT era changed the demand curve. Large language models made AI infrastructure feel urgent to almost every major technology company at once. Training and running those models required huge clusters of accelerated chips. Nvidia already had the hardware, the software, the developer base, the data center relationships, and the reputation. That is the moment when a long bet starts looking like genius. By fiscal 2026, Nvidia was reporting annual revenue above $200 billion, with data center revenue making up most of it. Those numbers are almost comically far from the company's early graphics chip gamble. But the shape of the story is consistent. A graphics chip was useful because it could do many calculations at once. AI needed exactly that at enormous scale. Huang's wealth comes mainly from owning a piece of the company that made that transition. Salary did not create the fortune. Equity did. The value came from Nvidia becoming more central to computing than almost anyone expected. There is a tempting lesson here: make a long bet and wait. But that is too cute. The better lesson is that Nvidia's long bet was not passive. The company kept adjusting. It changed after NV1. It fought in gaming. It invested in CUDA before the payoff was obvious. It built relationships with developers and researchers. It moved from chips into platforms. It turned one technical advantage into a business system. That is much harder than simply being early. Being early can bankrupt you. Nvidia survived because it was early and useful, early and adaptable, early and stubborn in the right places. So when people say Jensen Huang got rich because of AI, they are not exactly wrong. AI was the giant wave. But Nvidia had spent decades building the boat. And the boat started as a graphics chip for games. That is the part worth remembering. Sometimes the market that looks like a niche is really a training ground. Sometimes the weird technical obsession is a bridge to a bigger business. And sometimes the future does not reward the person who predicts it loudest. It rewards the person who keeps building the boring pieces until the future finally needs them. What do you think was Nvidia's real edge? The chips, the CUDA software, or Jensen Huang's patience in sticking with the same bet for so long? Drop your take in the comments, because this one is a good test of what vision actually means. And next time you hear about a company suddenly becoming an overnight winner, it is worth asking how many years it spent looking like a niche before the world changed around it.